This is the solution for the mock exam for functions for math 10th grade. Number 1, write or sketch 4 representations of functions using the following forms: an XY table, ordered pairs, mapping, and graph representation. First of all, just to review what each one of these things are. An XY table is a 2-column table. It's got X on the left, and on the right it's got f of X, or it's got Y. In the bottom it's got numbers. B, ordered pairs. Ordered pairs are XY pairs of numbers that we've been using since we were very young. C, mapping. Mapping is those circle diagrams where you have things on the left, which are the domain, things on the right, which are from the range, and we have arrows pointing from the left to the right. D, graph representation. Graph representation is basically XY Cartesian graph with a curve or a line in it. Okay, so now I'm going to complete these representations. So in the first one, I am going to put a few XY pairs in this table. And basically I can put anything I want to on either side, except I cannot repeat values of X with different values of Y. So for example, I cannot do this because I have 2 3's in the X's and they point to 2 different Y's, right? So I can't do that. Ordered pairs, it's pretty much the same thing. I can write the exact same thing I wrote for the XY table, like that. Mapping, same thing. I could have like 3 numbers here, and then I could have a few different numbers here. And one thing that confuses people a lot is sometimes they think, oh, I can't have more than one arrow point to the same number, but actually I can. For example, I can have both the 1 and the 2 point at the 3, because I can repeat X's for the same Y, but I cannot have a repetition of Y's for the same X, okay? So this here is fine, okay? Likewise, I could put a 3 here, for example. Both 2 and 3 here are both pointing to 3, for example. That's fine also. Graph representation. So a graph representation would be any curve or line, and a function would be any line as long as it's not vertical, or it could be any curve as long as it doesn't double back on itself. Let's go to number 2 now. First it says to copy each representation from the top. I'm just going to put it down here. Okay, and it says to modify one characteristic of each, so that each one is no longer a function; it's just a relation. So the way I can ruin these is, for example, for the ordered pairs, I can add another ordered pair, and this time I'm going to put that the 3 also points to 5. And here, do you see I have 3 pointing to 3, and I also have 3 pointing to 5. So that ruins the function. It's no longer a function. Now it's just a relation. For this one in B, the ordered pairs, I could have 2 pointing not only to 3, but I could point him also at 4. Okay, so I have 2 pointing to 3. I also have 2 pointing to 4. In the mapping diagram, instead of having 2 numbers in the domain pointing to 1 number in the range, I'm going to do the opposite. I'm going to have 1 number in the domain pointing to 2 different numbers in the range. So I have 2 pointing to both 4 and 3. Okay. And for D, instead of having this nice line here, I could draw, for example, a vertical line or I could draw a curve that kind of doubles back on itself, so I could have like that, okay? And this curve, which doubles back on itself, the way we can tell that it is not a function is because we can see that for a given value of x, like for this horizontal position here, I can see that there is a 2 points above and below the x-axis which correspond to that x position. Okay, so that's why this is not a function. If we wanted to maintain the shape of the line over there, we could put that it's a vertical line, because a vertical line also violates the vertical line test. It has infinite number of points, one on top of each other, so that is also not a function. Write down a domain and range for each of the representations in 1. So let's see, what's the domain for A? It would be 1, 2, 3. So the domain would be 1, 2, 3. And you could put x is an element of 1, 2, 3. Range. Y is an element of 3, 4, 5. Okay. B. The domain is an element of 1, 2, 3. The range is an element of 3 and 5. Okay. C. The domain is an element of 1, 2, 3. And the range is an element of, actually look, I'm not using the 4, right? I'm only using the 2 and the 3, so actually it would be 2 and 3. Okay, and last of all, in D, if it's a straight line like this, then x would be any real number, and y would be any real number also. So I could write that as x is any real number, and y is any real number. Okay, if I had like a curve, then maybe the y, like for example, let me do another example here. If I do a parabola, and the parabola starts at y equals 2 here, then the x, the domain, would be all real numbers, but the y would be any number above, did I say 2? So it would be y is greater than or equal to 2 would be the range. Okay? All right. Moving on to number 4. Analyzing your graphs from 1D and 2D, explain the test, rule, or check to determine if they are a function or only a relation. Okay, so we're going to look at 1D and 2D. Okay, so 1D is the graph. So how do we check the graph to make sure that that it's a function or a relation? And you could say, like for example, that you use the vertical line test. I use the vertical line test, in which I check to see if there are more than one point along a vertical, like there are more than one point, one on top of each other, something like that. Okay? Or you could say, if I draw a vertical line, it should not cross the function at more than 1 point. Okay. Number 5. Graph the following points on the grid and then connect each one to the next using straight lines. So I'm going to graph each one of these coordinate pairs. So -3, -3 is there. -2, -2 is there. -1, -1.5 is there. 0, -1 is there. 1, 2 is there. And 3, 3 is there. Now I'm going to connect each one of these pairs with a straight line. And then it says, using the graph, find f of -1. Remember the notation f parentheses? What goes in here is the x coordinate. So if it says find f of -1, you're going to use -1 as the x coordinate, and then you're going to see what that function is equal to, and that's going to give you the y coordinate. So let's go find f of -1. It's right here, right? X equals -1 is there. And then we're going to follow it down and look at where the graph goes. It's at y equals -1. Okay, so we're going to say the answer is -1. This is using the graph, find f of -1, 2.5. Now, if 2.5 is in the parentheses for the inverse function, then actually we're looking for a y value of 2.5. So let's see where that is. So y value of 2.5 is there, so that's actually here. And then we're going to follow it down, we're going to find the x value of 2. So actually, the graph is going to give us an x value of 2 when we look up the inverse f of 2.5. Last one, using the table, find the inverse function of -1. Here, again, we're going to find the y value of -1, which is right here, and then we're going to follow it to the x-axis, and we discover that this corresponds to an x value of 0. Okay? All right. Moving on. Answer the following according to the given function f of x. So here's our f of x function. And we're going to find the value f of 2. F of 2 means that 2 is equal to x. So we're going to put 2 in for x here. And we're going to get 6 times 2 minus 2 divided by 2, which is 12 minus 2 divided by 2, which is equal to 10 divided by 2, which is equal to 5. So our value here is equal to 5. From the result above, write down the inverse function of 5. Hey, we just found out that if you put 2 into the function f, you get 5 out. So the inverse function of f of 5 is going to equal 2. Okay. Next one. F follows g of -4. Find f follows g of -4 when f of x equals x squared and g of x equals x plus 3. Okay, so basically this means that the input is -4, and we're going to put the input of -4 into the g function. I'm going to rewrite both of these functions with the parentheses blank notation, just to make it a little easier to see what we need to do when we put in an input. Okay, so when we put -4 into the g function, we're going to get -4 plus 3. That's the g function. Then we're going to take this output, and then we're going to put it in the f function. So let's see what this equals to. It equals to -1, and then we're going to put it inside the f function. The f function is that, so I'm going to put -1 in there. -1 times -1 is positive 1. Okay? So I put -4 into the g function, and then the result, which is -1, I put it into the f function, and then the result was -1. Okay.